to evaluate this surface integral where S is a closed surface bounded by this cone and the plane Z equal to 1, right? And because the integrand is the product of this and n vector, that means we can use here the Gauss Divergence Theorem, right? Okay. So let V be the region enclosed by the surface S, and by Gauss Divergence Theorem we know that this given surface integral is equal to the volume integral of divergence of this vector. That is equal to the volume integral of, okay, the divergence of this vector is the partial derivative of first component with respect to x, right, plus the partial derivative of second component with respect to y, plus the partial derivative of third component with respect to z. So the first term gives 1, plus the second term is also 1, plus third term is 2z, which can be written as 1 plus 1, 2, 2 plus 2z, that is twice of 1 plus z. So this is twice of 1 plus z. Fine. We can take this 2 outside of this integral. Alright. Now we can write this volume integral as a triple integral and writing dv as dx, dy, dz. And now we need to mention the limits. Okay. To write the limits for x, the limits of x depends upon y and z. We need to write the limits of x in terms of y and z, right? So the cone is given to us. So here in this diagram, this cone is given to us, x² plus y² equal to z², and this plane z equal to 1 is given to us, right? From this cone, we can write the limits for x as, so x² is z² minus y², and then x is equal to plus minus square root of z² minus y². So the limits for x is from negative square root of z² minus y² and the positive square root of z² minus y², right? And now to write the limit for y. To write the limits of y, this y must depends upon z, right? So writing the limits of y in terms of z now. So to get the limits of y, we need to take x equal to 0 in this cone. So we are getting y² equal to z², and from here we write y equal to plus minus z. So limits of y, negative z to positive z. And finally we need to write the limits of z. That should be constant. And the value of z varies from 0 to 1, right? So the limits of z is from 0 to 1. I hope it is very clear to you. Now integrating this integrand with respect to x first. And when integrating with respect to x, this integrand is constant. So integrating 1 with respect to x, we get x with limits minus square root of z² minus y² and plus square root of z² minus y². When putting the upper limit, we get square root of z² minus y² minus putting the lower limit, we get negative of square root of z² minus y². So that becomes 2 times square root of z² minus y², right? So it is 2 times square root of z² minus y² dy dz. And also we are having 1 plus z as constant. Taking this 2 outside, it gets multiplied with this 2 and we get 4. And now we need to integrate this integrand with respect to y. And because we are going to integrate this integrand with respect to y, so this 1 plus z becomes again constant for this integral. And this is your even function. So whenever we are having the even function with opposite limits, the integral becomes twice the integral, the limits from 0 to z, and the integrand and dy dz. So now these 2 again multiplied with this 4 and we get here 8. And now we need to integrate this with respect to y, and for this integral, this 1 plus z is constant. So the integration is, writing here constant first, okay. So this is y divided by 2 square root of z² minus y² plus z² divided by 2 sine inverse y by z with limits 0 to z, dz. Putting the upper limit z in place of y, we get z by 2 square root of z square minus z square, that becomes 0, plus z square by 2 sine inverse z by z, that is 1, and sine inverse 1 is pi by 2, minus, when putting the lower limit, we get first term to be 0, plus second term z square by 2 sine inverse 0 by z, and sine inverse 0 is 0, and 0 multiplied with z square by 2 is 0. So we are having only this term. The denominator becomes 4, and taking this denominator outside, and also we can take this pi to be outside of this integral, and this get cancelled out with this, they get 2 pi. So this is 2 pi integration of z square into 1 plus z dz. Let's multiply this z square inside and we get z square plus z cube as the integrand. And now integrating this with respect to z. So we are getting the first term to be integrating z square with respect to z, we get z cube divided by 3, plus integrating z cube with respect to z, we get z to the power 4 divided by 4. And this is 2 pi. Putting the upper limit, we get 1 by 3 plus 1 by 4, minus, putting the lower limit, we get 0. So this is 2 pi into 1 by 3 plus 1 by 4, this becomes 4 plus 3 divided by 12, and this is 2 gets cancelled out with this, and we are having 4 plus 3 to be 7 pi by 6. So this is the required answer to that surface integral. Okay, thank you. And now the time for the thought of the day. Beauty is not about having a pretty face. It's about having a pretty mind, a pretty heart, and a pretty soul. Alright, thank you. Stay blessed.